All right, so what we got to do is get some reference points where we took the measurements.
Now that Jim and Tom and I have recorded 3 different points across the ranch where these radiation spikes keep occurring, we're gonna go plot them out on a map and see exactly where they intersect.
Right here is a spot, right?
We had right next to the helipad right there.
Right there, okay. And then we were out here by a power pole somewhere.
Right there's the shadow of the power pole.
Yeah, good, good. So right there. So there's 1, 2, 3. Let's see, and we'll need the angles that we measured from each of the points.
We figured out the angles that we were detecting energy from the sky at 3 different points, and these angles are gonna cross at some point above the ranch. Using some basic high school trigonometry, we can calculate that height.
This one was like that. And look, they're gonna cross up here somewhere.
Yep.
And this one was like that. So how high is that?
Who's got that calculator?
Yeah, it's 5,700 feet, 1 mile high. Do we ever see airplanes flying at a mile high over there? What does that mean even?
So 1 mile high is only about 1/6 as high as jets fly. That means that whatever is doing this should be seen by the naked eye. So why can't we? This just doesn't add up.
That is our next measurement. And the way we could do that is we tether a weather balloon and raise it up through that region that has equipment on it. We get it up there and see if we see something there. If we see something there, that's even more exciting.
That sounds like fun.
Hey, yeah, that's awesome.
Yeah, and every time we think we have an idea of a solution, the answer ends up being something weirder. Hey, Matt.
Hey, Travis.
How you doing, man?
I'm great. How are you?
Yeah, good to see you.
Good to see you, too.
Hey, this is Thomas,
Matt
and
Turner.
Jim.
Once we figured out that the strange energy source was coming from about 1 mile above the ranch, I called up a friend of mine, Dr. Matt Turner. He's from the University of Alabama in Huntsville. He's got a PhD in mechanical and aerospace engineering, and he's an expert in the use of weather balloons.
We've measured some really strong RF fields coming from the sky. And so we think there's a focus somewhere, and we're guessing that the focus may be as much as 1 mile high.
Yeah.
So what I'd like to do is set up an experiment, and let's start measuring that.
That sounds great. I got balloons, we've got helium, we've got some payload platforms, and we just need your meters, and we're good to go.
All right, let's get everything loaded up, and let's do that.
Excellent.
I think this is a good spot, guys.
Based on the triangulation of where these strange microwave and radio signals are coming from, what we're going to do is use a weather balloon with instruments on it to fly it through the point on the ranch where we believe this stuff is coming from.
All right, so with this balloon, with the tether especially, we should be able to pick an altitude and go to that altitude and measure with the tri-field meters and dial in the altitude that we want.
Nice.
So at the end of the day, if we could have a chart that says altitude, RF energy, and show the plot, that would be amazing.
After attaching one of our RF meters to measure possible radio or microwave energy, we've also attached a camera so that we can photograph what happens when the balloon's up in the sky.
All right, Caleb.
Fire in a hole.
Shut it off.
Okay.
Is that a lot of lift on it?
Yeah. All right, we're good.
Yep, we know.
Audio beacon is on.
We need to let it go, though. The wind's kind of dying down. It'll be a good time to let it rip. I mean, it's going to go like a rocket, right?
Yeah, it's gonna take off pretty quick.
Well, so we hopefully get it to go through the, mile high mark that we were calculating.
I'm just hoping that it hits that before it gets too far to the west.
I hope so, too. You got it, Matt? All right, here we go.
We're clear.
Good. Start easing it up. Start letting it go. Start letting it go. 3, 2, 1, let it launch. Look how fast it's going.
Hey, I love how it's going
And it's
right
going
towards
right
the mesa.
through the spot, too. That is awesome.
Oh, that is perfect. Right where it needs to be.
That couldn't have worked out better, I don't think.
It's a good launch.
I say we pack up and go back and try and track it on the internet.
Sounds good.
Yep.
All right.
Now that we have a successful launch, we're going to go track the balloon from the command center. If this experiment is successful, it'll tell us exactly where these energy spikes are occurring and hopefully what's causing them.
Are you tracking it already?
Yeah. Yeah, come sit down and take a look. Can you see okay?
Yeah, I can see good.
What does it look like so far?
Yeah, so we've got a few good hits already. It looks like it's tracking off towards the east.
How high is it right now?
It's given us an altitude, well, above sea level, 10,453.
Now, Skinwalker Ranch is already at 5,000 feet above sea level, and the balloon we're tracking right now is approximately 5,500 feet above the ranch. That means its total elevation is about 10,500 feet. Now, that's pretty much exactly where we believe the RF energy above the property is coming from.
Well, it is odd, though, because you'd think it had gone more than that in the time it took us to get out there into here.
Yeah,
Well, it's not, this is not updating.
that's strange to me. That's supposed to update every minute. It seems to have stopped after the 10,000 foot above sea level.
So, when was the last time that blip sent data? I mean, how long ago was that, Eric? A few minutes ago?
Yeah, it's been a lot more than a minute.
Okay, and that's baffling to me. This sensor is rock solid. Dude, I've flown this thing 30 times, more than 30 times. It's never failed on me. So I don't understand why it went out.
I'm kind of worried about this balloon. I don't think we've ever had anything that we could not explain in the atmosphere. We can usually figure most things out if we have enough data. Roughly a mile or a little bit above a mile high, and it's lost, which I never thought would happen.
So what altitude did you say that was?
Well, this is telling us 10,453 above sea level. So
What's the altitude of our?
We're at about 5,000 here.
Okay, so it's about 5,500 feet, right?
Yeah.
Well, that's interesting.
Yeah, it is.
So somewhere the sensor stopped working.
That's right where we figure those field lines are crossing.
It's right where the triangulation put it.
Oh, wow.
We did get it to ping as the balloon was going up. So we know it was transponding and sending information. The last ping that we got showed the battery was good, the temperature was good, everything was functioning properly. And then magically it hits this 5,000 foot mark and it's gone.
I've flown 30 of these balloons. I've dropped them, I've stepped on them, I've gotten them wet. They've flown through, thunderstorms.
They go up to 100,000
Yeah,
feet,
they're
right?
rock solid.
There must have been something at 5,000 feet that shut it off.
Something happened.
It's crazy that the point where we lost contact with the balloon is at the exact same altitude we calculated the RF energy to be coming from. But where the heck did the balloon go? It's like it just disappeared.
When we look at the footage from the tethered test,
Sure.
and what I'd like to see is the meter, so we can kind of see what it's doing.
Easy enough.
Whoa.
Look at that.
Oh, wow.
Look at that. Wow. So we're getting about 0.3 milliwatts per meter squared.
Thought I saw a spike at 5.
I thought I did too. That's like standing by a microwave that's on.
So this isn't someone just sending a Wi-Fi signal back and forth or anything like that?
It can't be at that altitude with these types of spikes, right?
Okay.
So one of the things that really jumps out at me is that you can tell if a frequency or RF energy comes from the ground, as most do, because it'll actually fall off as you go up. So in order to create something up there, you have to have an antenna up there to create the energy. So what's disturbing is that it has to come from something off planet. It's not something that humans have created on the face of the Earth.
That's crazy.
Yeah.
So the interpretation of this is there's something above us sending signals down.
It means, yeah, it's coming from above.
It's coming from off planet, right?
That is what the data is suggesting. A lot of this is not adding up.
Right.
So I'm sitting in a room full of baffled scientists then.
That sounds about right.